and I am recording as of now. We did start talking about the derivative. And we did make note that we use this long formula where the f prime x represents the symbol for the first derivative, and it's representing the limit as h approaches 0, given the function f of x plus h minus f of x and all over h. And this works if the limit exists. And so they make a note here, which I'm going to share with you. It says if that first derivative exists for each x in the open interval AB, whatever interval that may be, then f, meaning the function, is said to be differentiable over AB. So the process of finding the derivative is called differentiation. So let me write this down as a note, because you guys are also not just learning math, you're learning a language. So let me make sure you understand that part. So differentiation is the process of finding the derivative of a function. So that is just a basic definition. We also use the word differentiating, which is more like saying this is what we're doing, right? So if you ever hear the derivative of a function is obtained by differentiating the function, basically. The same thing, same concept. So I do want to talk about the interpretations of the derivative today, because I want to work you through a couple of examples where we actually differentiate, and then we use different values for x to find the value of the slope of the line, of the tangent line at that point. And I need you to make that connection really well. So we're gonna, that's why I stopped when I stopped last week. It wasn't, I was just tired. No, it was, I want to stop because I want to make sure you understand this part. Okay. So you're cool up to here with the notes?
Yeah.
Easy?
I'm
What?
the red.
You're on the red one?
Yeah.
So I can do this? Okay. So I'll give you a minute to catch up if you're doing that real quick. Let me know when. So this is the important part. Remember, math, like I said, is just another language. It just, if you understand the symbols, the interpretation, and its uses, then you've understood the math, basically. So the interpretation, this is where the applications come in, of the derivative. This is the interpretation of the derivative. So we can interpret the derivative as the slope of the tangent line on a function. That's one interpretation. We're going to discuss that. So we can also look at it as the instantaneous rate of change or we can look at it as the velocity. And funny, I was actually teaching MAC 1105 and we were on the chapter section 2.2, which covers the difference quotient. Remember we talked about that in this chapter, and I was explaining to them the connection between this and calculus, and they were like, mouth ajar, it's really cute. So those are the three ways we can use our derivative. And so let's let me give you something else to chew on for a minute. So we talk about a function, right? F of x. We refer to this as the displacement function. It tells us where the object is at any particular point, so you can see the actual function. That first derivative, we kind of associate it with velocity. So how fast is that object going at that particular time in x? And the second derivative, which I'll show you I think I did show you already, is that's acceleration. If you can remember this, you've got half your battle fought. Displacement, velocity, acceleration. Remember, this is the initial function. This is a function itself. This is the first derivative of the function. Can I just put first der? And then this is the second derivative. And this you can do if it's differentiable. If it isn't, then we stop. So let's talk about example 4 again. And then I'll give you another example similar to that. Well, unless you feel that you got it, right? So let's go with that. Are you cool? Moving on? You cool? All right, so we begin with finding the derivative. Call it example 4 if you wish. So we're going to find the first derivative, which is that symbol right there. The derivative for all x for the function f of x equal to 4x minus x squared. Now, if you want to use the 4-step process or you want to use the short version I showed you, up to you. Either works. Either one is going to get you the hot prize. So in the directions, they do want you to do this with the 4 steps, which I think is overkill, but we'll do it anyway. So we're going to start with step 1, if you wish, which in step 1, we're going to find f of x plus h. And so that means that we're going to use f of x plus h, and we're going to substitute that into our equation, 4 parentheses x plus h minus x plus h squared. And so the next step here is going to be to do FOIL and extend our terms. So obviously 4 times x plus 4 times h is simply 4x plus 4h. minus, and I like to put a bracket here, we're going to FOIL that. So remember, that's x plus h times x plus h. I'm going to do this a really long way so you see the whole thing, just in case. And that's squared. Okay, so notice I'm not even paying attention to this little minus sign yet. I'm just looking at the FOIL here, okay? That gives me x squared plus xh plus xh plus h squared. Remember, that's coming from inner, outer. That's where this is coming from. And so now I put it all together, and I've got 4x plus h. I'm sorry, 4x plus 4h. And now I'm going to distribute the negative here, right? So pay attention here, because all that's going to get affected respectively. And you end up with this minus x squared. Obviously this is 2xh, so it'll be minus 2xh minus h squared. That's just the first part, right? Now we take away the f of x, so I'll do another parentheses, minus 4x minus x squared, which is your f of x up here, right? Because remember the formula, it's f of x plus h minus f of x. This f of x, if you look at the highlight, is that green. That's what this is. Now we're going to distribute the negative. Just remember, this is all over h. Okay, and patiently we'll write it again. 4x plus 4h minus x squared minus 2xh minus h squared minus 4x plus x squared. That's the whole numerator, and all of this over h. Which means in pink, if you look carefully, the 4x cancels with negative 4x. The negative x squared is going to cancel with the positive x squared. And something else cancels. Well, eventually the h is going to cancel. I think that's it, actually. So you should be left with 4h, you are, minus 2xh minus h squared. So if this is 4h minus 2xh minus h squared over h, you can go ahead and either reduce it right away just by dividing each term in the numerator by h, or you can factor out h in the numerator, and you're going to get 4 minus 2x, nice, minus h, and all of this is over h. But remember, these h's are going to cancel. That cancels with that. So now you have 4 minus 2x minus h. And what you need to remember is we're evaluating this, and we're going to say as the limit, this is the limit as h approaches 0 of that term, which leaves us with, basically, if you think about it mathematically, you have 4 minus 2x minus 0. We don't really write that, right? So our final answer is just going to be 4 minus 2x. So that's the first derivative of this equation. Do you want to try one on your own in the 4 steps, or do you want to be a rock star and do the Barrazo?
I'll be a rock star.
Let's do the Barrazo, just for funsies. So we see that here's your displacement, and that's 4x minus x squared. Right? And if we want that first derivative, we're just going to take f prime x. All right? And remember, this is x to the 1 power. Remember this, the process. It's the exponent times the coefficient, which gives you the number. So that's 4. Take away an exponent, nothing is left, right? Because 1 minus 1 is 0. X to the 0 is 1. I don't need it. But this one, remember there's technically a 1 here, so this is minus 2x and take away 1, so this is really x to the 1. So it's multiply exponent times coefficient, take away an exponent, and that's your term. All right, so that's the same way, or one of the ways you can beat the system. However, remember, if the test is on Pearson, they may ask you to do the steps anyway. No. All right, you want to try one on your own or move on? Yes, one on your own? All right, so let's try. So I'm going to give you this one to try. Let's, and this time we're going to do the 4 steps and the Barrazzo, so you could do both. So find the first derivative. So I'll just write the directions. The derivative of f at x for all f of x equal to 8x minus 2x squared. Right, you could use a 4-step method if you wish. I would recommend it. Or just find the first derivative. And then we'll go to the next example. And so here are the 4 steps, by the way, because you probably don't remember these from last week. So step 1 is to find f of x plus h. Step 2 is to find the value of the numerator. So you're going to do f of x plus h minus f of x. In step 3, you're going to do the whole thing. You're going to put the whole enchilada together. So find f of x plus h minus f of x all over h. And in step 4, they just want you to find the limit. As h approaches 0. Why suffer? Oh, because Pearson. Just in case. Just
How
do
do
it.
you find out? Like that?
Because they might ask you what the answer is for each step. They might have it broken down as a 4-step thing. You have to fill in what each one is.
Yeah. And you have to like show the work.
No. I mean,
Try to avoid those.
How do you find out this method right here? The one you got.
Oh.
25 years of teaching. Actually, for me, it was like the first semester. I was like, I had a Russian teacher. The guy was like, I'm listening to him and I'm like, what is he saying? Like, I couldn't understand his language. It was bad. It was very heavy accent. I can handle accents, but that was just rough. And he was fast. He was like he's talking, and like he would not slow down for us. And I said, I'm gonna have to learn this myself. And I just got ahead. And then when he was doing stuff on the board, I already knew what he was doing because I had done it ahead. That's the only way I could have learned in that class. I was not having it. But there actually is a formula that they show you, which when you look at it, it's like hieroglyphics. It's awesome. No, but it's like, I'll bring it in. I don't even remember what it would look like, but all the symbols and all that, it's crazy. So some of you are still suffering. We're doing it this the long way. So if we're doing the long way, you should have 8 minus, no, actually that is the derivative. So sorry, 8 times x plus h. 8 times x plus h. Minus 2 parentheses x plus h squared. That's what you should have started in step 1. So I'll call it S1. And so you have 8x plus 8h minus 2, actually minus 2 bracket x squared plus 4xh plus h squared, correct? And that's just the numerator.
Would it be plus 2h squared? Or, I mean, minus 2h squared?
Oh, I missed the 2, yeah, you're right. And then minus the f of x, which is our lovely original. And all of this over h. That's what you should have. This should actually be at this point your step 2. Actually, by now you're at step 3. So this is like steps 2 and 3 together because this is the whole thing. If you open it up, you have 8x plus 8h minus 2x squared minus 4xh minus 2h squared minus 8x plus 2x squared. All of that over h. So this cancels with this. 8x and negative 8x go away. They cancel each other. And you should be left with 8h minus 4xh minus 2h squared all over h. So let's extract the h. Okay, so that leaves me with 8 minus 4x minus 2h and all of this over h. All of this cancels, and now we're at step 4. In step 4, we're looking at the limit as h approaches 0, and they're giving us 8 minus 4x minus 2h. Obviously, h becomes 0, so that cancels totally. And you're left with, like I said, the first derivative, 8 minus 4x.
Is this plus h or 2h? Is
The
8
two-
minus 4x plus?
Minus 2h again. It's going to cancel. This is all going to cancel. Because remember, the limit goes as h approaches 0. So it goes away. Okay. How many of you feel confident now? You're good? You want to try another, or you want to move on? For example, 5?
Can you show us your method again?
Yeah, sure. So let's use, do you want to use the same one we did?
Yeah.
So here's your displacement, which is 8x minus 2x squared. Okay. So the first derivative, see how technically there's a 1 there? So you start with exponent times coefficient. So that's 8. Take away 1. X to the 0 is really just 1, so I don't do anything. I don't need to put that there. 2 times 2, that's 4. Take away 1, that's x. That's it. You want to see another example of that real quick?
Sure.
Okay, so here's displacement. Displacement function. Let's make this a little longer. So what if I have 16? Oh, let's not be cruel. Let's do 4x to the 5th power minus 2x to the 3rd power plus 6x to the 2nd plus 7. You're going to differentiate. That's what we're doing. So wouldn't this be 20x to the 4th for the first term? 20x to the 4th minus 3 times 2, 6x to the second, right? And then plus 12x, and then we stop, right? Because in theory, a constant is always x to the 0. Because x to the 0 is 1. So 0 times 7 is 0. Goes away. Goodbye. Any constant always goes to 0. Easy. Okay. What if I wanted the second derivative? Tell me. What do you think this one is? 80x to the third
minus 12x.
minus 12x, and then
12.
plus 12, because remember there's a power of 1 here. You got it? So it's always exponent times coefficient first. Exponent times coefficient, take away 1. Okay, so let's go back to our original question in example 4. Go back to the function. And remember, in theory, in practice, in practicality, because I believe if I'm going to teach you calculus, I need you to understand it from the ground up. The derivative itself is like a master key. Like if I had a master key to this building, what would it do? Open every, yeah. So think of it like a master key, but what it does for you is it gives you the value of the slope of based on x. Okay, so I'll show you as we go through the example what it means. So this is example 5. And so the question stem here says we're finding the tangent lines, the slope of the tangent line, or the way they wrote it was finding tangent line slopes. The thing is, once you have the derivative, you've got the equation you need for any point on that diagram at any given point. Watch what I mean. So they're saying we have the function f of x is equal to 4x minus x squared, and found the derivative, the first derivative at that, to be equivalent to 4 minus 2x. So the interpretation is, so the line or the slope, so the slope of a line tangent to the graph of f at any point given x, f of x is equivalent to, the slope is the first derivative of x equal to 4 minus 2x. So that is the gist of this concept. This is the gist of the tangent line and that first derivative. So for part A, this is what they're asking us to do. They say find the slope of the graph of f. Oh my gosh. So give me 1 second. A graph of f, as in the function, at x equal to 0, at x equal to 2, and at x equal to 3. So we're going to start with that question, or that set of points. And so to answer this, look at what you're answering. Find the slope of the graph of the function. So they're starting us with 3 different points. So we're going to start with the first derivative at 0 equal to 4 minus 2 times 0, which gives us 4, which is the slope at x equals 0. Let me stop right here for a moment because I want to draw you the picture. So let me go to Desmos for 1 second so you see. Okay, so we're going to go to Desmos and we're going to graph f of x is equal to 4x minus x squared. We're looking right here at that point 2, 4, right? What do you think the slope is? Literally just a line going straight through the top, which is flat. It's horizontal. If you have a horizontal anything, what's your slope? 0. Yeah. Does that make sense? Is there anybody who doesn't see it, doesn't understand it?
Can you repeat it?
Sure. Okay, so you're looking at this little point up there, right? There technically is, the horizontal line is nothing more than a line going straight across the top horizontally. Like, let me draw this picture over here. Same picture, same concept, okay? Let me go back. So here it is. It goes like this, right? So at this point, which is right here, you have a little flat line going like this, which is the slope of the line. This is where m equals 0. Anytime it's horizontal, it's always 0. Right? And anytime it's vertical, we know it's undefined, right? All right. What happens as I look at this graph? Let's do part B. We're looking at the first derivative at the point where x is 2. So if I go back to the graph and I look at x is 2, let's see here. So that means that we have 4 minus 2 times 2, which means that the slope at x at this point is equal to 2. Okay. The next one is, if I'm looking at the first derivative at 3, the value of the slope will be 4 minus 2 times 3, which gives us negative 2. So that is the value of the slope at 3. So let's take a look and let's make sense. Let's look at this one first. So at 3, actually, when x is 3. So I'm going to do this just to highlight where x equals 3. Where x is 3, I'm looking at that point right there. Does it make sense to you that that's a negative slope? Remember, left to right, what's happening? We're going down. As opposed to, say, at, let's see. So at 0, 0, which is this point here that we were also talking about, that slope is actually positive 4. Does that make sense? That it would be positive and it would be 4? I mean, left to right, what's happening? You're ascending, yeah. And you can do that for all infinite points around that graph. That's the beauty of it. And that's where piloting comes in. Like if you think of a pilot and how they know when to turn a plane or how to adjust, that kind of thing. So, one more example, or do you feel like you understand that? Understood?
For f prime of 2, why would it be x equals 2 if you get 0? Versus x equals to 0 and you plug in for.
Because that's like 2 is where you place on like the horizontal line.
Okay.
That's there. That's not what you're talking about. So yeah, you're focused on the domain at that point. Okay, are you all clear? Yes? Promise me. Don't lie to me. I'm very sensitive. All right, here, let me talk you through this next example. Now, I've shown you nice equations so far. I haven't been mean to you. Now I'm gonna throw a fraction at you.
Oh,
Frickadoodle.
lovely fraction.
Nah, it's not that bad. It's really not that bad. And we are gonna do it with the, I'm gonna show you again the trick, the Barrazo method. But I'm also gonna show you with the 4 steps. So we're gonna start with example 6 then. In example 6, we're finding the derivative. So they're giving us the following. They say find the first derivative. And you know it's the first derivative because there's only one prime. The derivative of f at x for f of x equal to 1 over x. Ay, Chihuahua. And yes, you can do this with that easy method. But we're going to do it the hard way first because the book wants you to learn it that way. So we're going to start with step 1, which is to find f of x plus h. Okay, remember the formula is f of x plus h minus the f of x and all of this over h. So we already know 1, we already know this because they gave it to us. How nice of them. But we are going to find this guy now, f of x plus h. Okay, so we're going to start with simply substituting it. So it's 1 over x plus h. We found it. There it is. Okay, in step 2, I'm going to try and follow this one step by step because I tend to go quicker. So we're going to find the f of x plus h minus the f of x. So starting with this, we know that f of x is 1 over x. So we're simply going to rewrite this as 1 over x plus h minus 1 over x. If we cross multiply, because remember we need a common denominator, right? So if you remember, the theory is if you cross multiply the denominators as such and then group them together, your answer here is simply x minus x plus h. If you want, I can color code it if you're not following me, over x times x plus h. If you have trouble with that, let me know right now because I could fix that for you. You clear? You see how? No, you're not clear? Okay, look at here. Let's make this blue right here. So I'm multiplying in this step right here, x, that blue x times 1, which is just x. Does that make sense? And over here, this is x plus h. And I'm bringing that up here, but it's times 1, so yay. Here's x plus h. You keep the negative outside because that's eventually going to get distributed, right? Now the bottom, that's just multiplication. This is the x that you see here. This x right there, times parentheses x plus h. Now you've combined now you've gotten a common denominator and you can actually work out the problem. Yeah? Okay, so when all is said and done and you distribute this negative, you end up with x minus x plus h. I know. X minus x plus h all over x times x plus h. So obviously, who cancels?
X.
Those cancel out, right? Your final answer,
Negative and negative H.
you're correct, look at you. Yeah, so your final answer here will be negative h over x times x plus h. So far so good? Comprendi? Alright, and now we are going to do the math with the h. Since I have negative h, this is step 3, and again, I'm slowing down so we can follow the book. This is negative h over x times x plus h, but remember, all of the equation is divided by h, which in theory, if you follow this carefully, is really h over 1, isn't it? And we are multiplying two fractions, or at this point, we're going to end up keep, change, flip. Do you remember that?
Yes.
So keep, change, flip. Reciprocal, right? So the h's are going to cancel. And now you're left with negative 1 over x times x plus h. Fine. This is now where we're focusing on the limit. This is step 4. So I'm going to leave it in red if that's okay with everybody. So when you look at this, you're saying the limit as h approaches 0, given the function negative 1 over x times x plus h, and then this is going to result in negative 1 over x squared, where x is never equivalent to 0. So this is the derivative, f prime x, for us, the first derivative of negative 1 over x squared. And of course, now we're going to plug stuff in and solve and all that fun stuff. Do you want another one to try? I got time.
Yeah, we'll learn
Yes,
your way.
yes, I see yeses, huh?
Can we learn your way?
Okay, yes, you absolutely can. Thought you'd never ask. No, I'm kidding. All right, so what was the equation? It was, okay, so you have 1 over x, right? 1 over x to the 1, correct?
Mm-hmm.
Okay, so is it not true that if I bring this up, this becomes 1 times x to the negative 1?
Yeah.
Super. So, ready? Negative 1 times 1, well, that's negative 1. And I have to take away 1. Doesn't that become x negative 2? And we don't like negative 2 for the exponent. So guess what we do? We drop it like it's hot. Isn't that cool?
It's so much easier.
What?
I have to show you everything. I have to show you the way the book shows you. But what I like about this is that you can mentally check your answer. That's what I like. So if I could do that, I'm happy. You want to try one more just for funsies?
Sure.
Let's try one more. Let's do negative 2 over x cubed. I'm going to show you another one after this that's a square root, because that'll tie to the application problem that we're going to do after that. Okay, just out of curiosity, step by step, so you don't miss a step, because you can miss a step and then... So first thing you're gonna do is say, well, isn't this negative 2 times x to the negative 3? Yes, it is. Once you do that, the next step now is to multiply negative times negative is a positive, 3 times 2 is 6. I'm gonna take away 1. That leaves me x negative 4, right? So isn't your final answer 6 over x to the 4th?
No, because we have simplified. No.
There's no simplifying, it's an exponent. Yeah, so that's it. Cool. All right, let's do example, what did I just do? Example 6?
Yeah.
Let's do example 7. Example 7. We're still finding the derivative. The only thing is, this is going to involve the square root. So get ready. Find the first derivative, which is the derivative of f at x for f of x equal to the square root of x plus 2, not the same thing, not under the same root. So we're going to do this in steps first, and then I'll show you the trick. Okay? All right, so we're going to have step 1. The first thing they want us to do is find the f of x plus h. And so we're going to basically rewrite this as this being equal to the square root of x plus h plus 2. Step 2. We're going to write this as the numerator. So we're going to write this as f of x plus h minus f of x, which we already have. So what we have here is the square root of x plus h plus 2 minus the square root of x plus 2. That's all they want us to do right now. This is step 2. So that means that I have the square root of x plus h plus 2 minus the square root of x minus 2. So this cancels, this cancels. The result of this step, it will be simply square root of x plus h minus square root of x. Okay, so far so good. Step 3. Step 3, we're throwing it into the entire equation. So we're actually going to say square root of x plus h minus the square root of x all over h. Conjugate, sound familiar? The word conjugate?
Yeah.
Okay, so we are going to multiply top and bottom by the conjugate of the numerator. So x plus h, square root of x plus h plus the square root of x, top and bottom. I'm going to multiply that top and bottom. This might be a slight nightmare. So that's the first step. So just remind yourself, multiply by the conjugate of the numerator. No crying in caucus. All right, so we're here. If I FOIL, I'm going to write this out the long way. So square root of x plus h minus the square root of x. I'm just doing the numerator first, so please be patient. Because, like I said, do you see where we're going with this? This is just this part. That's just that part. All right, so if we do FOIL, remember first terms, this times this, is just going to leave us x plus h. We agree? Second term, or second terms, inner, outer, those two are going to cancel because they're the same thing multiplied against each other, right? So that cancels. Last term. The last term is going to be a negative symbol, and square root of x times square root of x is really just x. If you don't know why mathematically, remember square root of x is nothing more than x to the 1/2. What happens if I multiply square root of x times square root of x? Am I not multiplying like bases? And does that not mean that I add their exponents? So if I'm adding 1/2 and 1/2, isn't that a 1? So x, right? So that's the numerator, yay.
Wow.
And now we're going to multiply these two together. So that's going to leave us with h parentheses square root x plus h plus square root of x. And that is our current denominator. Okay, remember that in this case, the x's are going to cancel. Right now, we are down to h over h parentheses square root x plus h plus, and all that underneath there, over plus square root of x as well. So these two are going to cancel, and you're left with always at least 1. So you're left with 1 over square root of x plus h over square root of x. That's it. Step 4, we're going to say, so this is step 4, we're going to say the limit as h approaches 0 of 1 over square root of x plus h plus square root of x. So, yeah. So when you're done with all this canceling, so you know h is approaching 0, you end up with 1 over 2 square root of x as your final derivative. You okay with that? Okay, so that's your first derivative. Now remember that x has to, in this case, because it's a square root, especially because it's in the denominator, it has to be greater than 0, or equal to 0 or greater than 0. So this is our first derivative equation, which is 1 over 2 square root of x. And yes, x has to be a number greater than 0. It can't be equal to 0 because this is 2 times, and you cannot have 0 in the denominator. So just a note, when it comes to a square root, I can have the square root of 0. That's okay. In this case, the reason why we cannot is because it's in the denominator. We cannot have 0 for a denominator, right? 2 times 0 is 0, no good. It's indifferentiable. All right.
You have a shortcut for this step?
Sure. Let's try one. So remember, in this step, you have an f of x that is equivalent to x to the 1/2 power plus 2, which is in theory x to the 0 power. Here's what we know. This is going to go away, for sure. This is going to become, so remember there's a 1 here, so it's really 1/2 x, and I'm taking away 1, so it's really negative 1/2. So this actually becomes 1 over 2 square root of x, because it's really 1 over 2x to the 1/2, right? Because I moved this down. Make sense? So you still can do that. Need that again? Okay, so Okay, so they're gonna give us example 8, which is a sales analysis question. So this is the application to this entire section. You know what I would love, and I haven't seen this in a while, is the lesson on derivatives with respect to investing. Like when you see the derivative of a stock, like when and when to. That's a great lesson. Let me see if I can find you one. What's that? In blue. Yeah. Okay. So this question is an application question. It's a sales analysis. It says a company's total sales in billions of dollars T months from now are given by S of t is equal to the square root of t plus 2. Find and interpret S of 25 and the first derivative of 25, and then use these results to estimate. I'll bring that back down in a minute. The total sales after 26 months and after 27 months. All right, so there's your question. Think about it for a minute or two and think about what you're going to do. I'll give you a hint. Go right back to the question we just did. Find that first derivative. So if I'm evaluating this, isn't this basically the square root of 25 plus 2 for the f of x? And isn't this going to give me 7? And if I'm evaluating that first derivative, again, I'm obtaining that first derivative. It should look like 1 over 2 square root of t based on the previous example. So in theory, shouldn't that be equivalent to 0.1? Because you're going to get 1 over 10, which is 0.1. So 25 months from now, the total sales will be 7 million and will be increasing at the rate of 0.1 million which is 100,000 per month. That's what this means. Let me say it again. So 25 months from now, the total sales will be 7 million, because that's what this represents, 7 mil. And it is increasing at a rate of 10%, or the equivalent of 0.1 of a million, which is $100,000 per month. Good to know. I'm in. Now, if this instantaneous rate of change of sales remain constant, the sales will grow to 7.1 million after 26 months. Let's find out. Do the math. So 25 months, I'm at 7 mil. If it's growing at a constant, this is gonna grow to 7.1 mil, isn't it? And at 27 months, if it's growing at the same consistency, isn't this 7.2 mil? And same thing goes on and on and on. It provides a useful estimate, yeah, I'll give it that. And so if I were to use the S of 26, just to continue, wouldn't this be equivalent to the square root 26 plus 2? And S of 27, wouldn't this be equivalent to square root of 27 plus 2? And this comes to, in your calculator, this should come to 7.099, which is approximately 7.1. And this comes to approximately 7.2 because you get 7.196 in the calculator. Not expected to know that right off the top of your head. How do you feel? Does that make sense, what you're talking about? All right, cool. Well, unless you want another example, that's what I got for you. I do want to make a note, one little note, and then we'll call it a day. And this is non-existence. Is there such a thing as a non-existence of a derivative? And you need to know this. Because you know that stuff we learned in 2.2 and 2.3 about limits? Yeah, that. So if the existence of the derivative at x equal to a depends on the existence of the limit, so this depends on the limit existing at x equals a, little shorthand, at x equals a, because if that does not exist, then we say that the function is non-differentiable. So if this does not exist, if the limit does not exist, we say it is this again, more language, differentiable. At x equals a. So therefore that first derivative at a does not exist. We will see some of those soon. Okay? So just know that that's where we're heading. I'll see you guys Wednesday. Happy you too. This is where I stopped.
I'm not gonna like tell myself, do you take attendance or no?
Yeah. Did anybody not sign in? Sign in's right here.